Hello everyone, welcome to my channel, and this is oxidation reaction part 2. And in this video we are going to discuss the different three different types of name oxidation reaction, and that is, at first one is the relay oxidation, and the second one is Swern oxidation, and the third one is Fétizon'S oxidation. Okay, so now see, this is relay oxidation, and relay oxidation is basically the extension of selenium dioxide based oxidation. And in the first video we have seen that how the selenium dioxide oxidation is occurred in the olefinic system. So this is also a kind of selenium dioxide based oxidation. So here, see, first this is you have given a ketone like this, and this has a alpha position, and this is the alpha position, and this is alpha position has a methylene group, that is CH2 unit, that is CH2 group, and this CH2 unit first automerized to this OH, and this in this form, and after that there is a you have given the selenium dioxide, and this selenium dioxide at first it go back here, and you all know the structure of selenium dioxide like this. This bond will attack on the selenium atom, and after that there is a formation of this one, and this bond will go back to form this OH. And now there is an important thing, that is a different type of rearrangement will occur in this system, and that is this hydrogen, and this will this oxygen lone pair will abstract the proton from here, and these bonds go here, and this will leave from the system as a water. So now now there is an important thing, is that this type of rearrangement, this is kind of rearrangement, and this type of rearrangement is called Palmyra rearrangement. So okay, so this Palmyra I will show you in other video when we are starting the rearrangement series, in the where we are, then we see that how the Palmyra rearrangement will occur. Now for this video, Palmyra rearrangement. Okay, I will show you in others video. Okay, so now this is your product, and after that the water oxygen has a lone pair of electron, and it will attack over this carbon, and this bonds will go here, and so this as a negative charge over the selenium atom, and this negative charge will abstract the proton from this water, and this is H, and this is from OH, and there is after that there is a formation of this ketone by leaving of this system. This overall part is leave from the system, like if you see like here, this bond go here, and this overall part leave from the system in the form of H2SeO. Okay, so there is a formation of 1,2-dicarbonyl. Now see, there is a one I am written here. So if there is a compound like this, there is a methyl over here, and there is a methyl. Okay, so there is a alpha position, and this is your methylene group, and this, if you have given this selenium dioxide, then your product will be like this. Okay, so this is the overall relay oxidation, and the selenium based oxidation is complete here. And now we are starting the second oxidation reaction, that is Swern oxidation. Okay, see, now see, here is the Swern oxidation. Now Swern oxidation. So at first we are starting this. Now we are starting this Swern oxidation. Okay, so this is a lookalike. We are done in the first video in part 1, that is Clayden oxidation. Okay, so this is almost similar type of Clayden oxidation. So if you have not seen yet from my part 1 of this oxidation reaction, then you can go over here and check out that video. Then you can easily understand this Swern oxidation. Okay, so I will teach you here, and how I will show you how the Swern oxidation will occur, and what is the mechanism of this overall oxidation reaction. Now at first you have to know what is the reagent of its. Now the reagent of its is basically number 1, that is COCl whole 2. and it is called oxalyl chloride. Okay, and now you have, and the second reagent which is used in that is DMSO. You all know that dimethyl sulfoxide. Dimethyl sulfoxide. Okay, now another important part is that you have to put a solvent like DCM, and there is a solvent here, that is DCM. That is DCM means dichloromethane, that is CH2Cl2. Okay, and the third is you have to put a base, and base is like ET3N. We already know in the first video that in the Coricum oxidation is here is also use this base, triethylamine. Okay, so now let's start the mechanism. And okay, there is an important thing is that there is a in this Swern oxidation oxalyl chloride is used, and there is another reagent which is also used in the place of oxalyl chloride, that is TFAA. I am writing here TFAA, that is trifluoroacetic anhydride. The structure of the trifluoroacetic anhydride like this. Okay, so now if there is no solvent is used, like TCM or any other solvent is not used in this type of Swern oxidation reaction, that is there is only COCl2 or trifluoroacetic anhydride in presence of DMSO is used, then it is very much explosive. So you have to make very much a precaution. So this is for your general knowledge, not for your exam purpose. Okay, so now let's start and do the mechanism first. Now see what is the mechanism of it. Now first there is a two steps of oxidation. Two steps of type of mechanism. Okay, at first in step 1, that is activation of dimethyl sulfoxide by using this oxalyl chloride. Okay, with oxalyl chloride. Okay, so this is your first part. Now see what is the mechanism. So we all know the structure of DMSO. So DMSO is the structure of dimethyl sulfoxide here like this. Okay, so there is a 2 dimethyl and this bond is called sulfoxide, and so this is dimethyl sulfoxide. Then we have written this structure in the form of this way also. That is, this is negative. This is just because of oxygen is more electronegative than sulfur, so oxygen contains a negative charge, so the bond is breaking like here. Okay, so now you have to put oxalyl chloride. Now what is the structure of oxalyl chloride? Oxalyl chloride, the structure of oxalyl chloride is this. Now this oxygen, this negative charge will attack over this carbon atom, and this bond will go here, and this is backed is O minus, and O minus is backed in the carbon, and this Cl is leave from the system. Okay, so the overall mechanism, after product of this type of reaction is that is C double bond O, and this is, there is this oxygen, sulfur. I am writing here, there is a oxygen and sulfur, there is a methyl, and this is positive charge. Okay, now see, you have the free Cl minus, so this free Cl minus will attack over this sulfur atom, and this bond, now these bonds will go here, and these bonds will go here, and like this. Okay, now see, there is a 2 different types of product will obtained from this reaction. The first one is this one. Okay, now the second part is there is a removal of this carbon dioxide. Now this part will remove as carbon dioxide, that is CO2, and this part will remove as CO, that is carbon monoxide, and the other part is remove as, that is free Cl minus. Okay, now see, this is your intermediate, and this is called chlorosulfonium salt. Putting here chlorosulfonium salt. Okay, so now this is your step 1, and now you have to make your step 2, that is activation of the alcohol. Activation of alcohol. Okay, just because of this kind of oxidation, so you have to put you have to convert this 1 degree or 2 degree alcohol to aldehyde or ketone, like so. You have to put your alcohol. So I'm writing here this is your Ne and your Cl, and I'm taking alcohol like this. This is a 2 degree alcohol, and it's a lone pair of electron, and this lone pair of electron will attack over this sulfur atom, and this Cl will leave from the system. Okay, now see, this is your oxygen, R and R prime, and now this is sulfur, CH3. Okay, and the oxygen hydrogen is, this is like minus of H plus, and now there is, now you have to put that, now this Cl and this H plus will remove from the system in the form of HCl, and now you have to put the base, and here is the role of, very important role of this base, that is, this is the acidic proton. So this acidic proton will abstracted from here, and there is a formation of negative charge over the carbon atom. Okay, so this is also your acidic, but it's not too much acidic like from of this. So this is much more acidic over this hydrogen. Okay, so now your product of this, after the removal of this hydrogen, that is sulfur. Okay, this is positive, CH2, here is a minus charge, CH3, and this your hydrogen, and this R prime and R. Okay, now there is a kind of, this is one type of rearrangement, like this negative charge will abstract this hydrogen from here, and these bonds will go here, and this will leave from the system as Me2S. Okay, so after this you get, this is your aldehyde, and your side product is like this. Okay, now there is a important, this is the overall mechanism. You can see here, this is the overall mechanism of this Swern oxidation. Now there is a one more, this is an important concept, that if the base is not used, only the DMSO or the oxalyl chloride is used, then what will be your product? And this question is also asked in CSIR exam. I didn't remember the exact year actually. So the compound which is given in the examination is this. This is your allylic alcohol, and you have given this DMSO and COCl2, that is oxalyl chloride, and base 83N. So what will be your product? And here is given that DMSO, COCl2, and there is no base, only the temperature minus 60 degree to 0 degree. Okay, so what will be your product? So there is a different type of product we already seen in the co-reagent oxidation. You can check over there in the first video of oxidation reaction. So this is your aldehyde. We all know that this is your allylic alcohol, and this is your oxidizing agent. It will oxidize allylic alcohol to this aldehyde. So if the base is not used, then there is a formation of this product. And how this will occur? And if you check here, that if this rearrangement is, if the base will rearrange this product, overall product. So if the base is not put here, so we have seen here that this will remain as this form. This will remain as this form. So we have a free Cl minus, that is this Cl minus will free from here. So this Cl minus will attack over this carbon atom, and this will leave from the system. So you get this product. So this is this type of reaction is here. This type of reaction is happening here. Okay, so this is your overall product. So this also the question is came in CSIR exam. Okay, so this is the overall Swern oxidation. Now see, there is one more important thing, and the last thing of this video only, that is Fétizon'S oxidation. Okay, that is Fétizon'S oxidation. Fétizon'S oxidation. Okay, so see what is Fétizon'S oxidation. So what it can do? It can do all the same thing that any oxidizing agent like Swern oxidation, Clayden oxidation. So it will oxidize the 1 degree, 2 degree benzylic or allylic alcohol. So the reagent which is used, that is, they're different, not too much different. Like this is called silver carbonate, that is Ag2CO3. In the important, that is not important, but it is used, that is in cellite. Okay, so what is cellite? Cellite is just nothing but the so let's see here. Cellite, it contains around 80 to 90% of silica, that is SiO2 silica, and the 2 to 4% of alumina, and there is a negligible amount of, that is 0.5 or 2%, less than 2%, that is iron oxide. This is your overall silica. Okay, so this is absorbed over this silica of this cellite, and it will oxidize by using this single electron transfer method, you can say. And there is another kind of proposed mechanism which I am writing here. Okay, so let's do the mechanism. So now what is the mechanism? Okay, now we have taken this kind of, there is the hydrogen. Okay, this is your secondary alcohol, and you have to put this Ag2CO3 on cellite. Okay, so this one AgOH. Okay, so this oxygen has a lone pair of electron. Is this lone pair of electron attack over this silver atom, and this bond will go over this oxygen atom, and negative charge over the oxygen atom. So now after that, there is a formation of this product, that is Ag hydrogen, and this oxygen is positive, that is R and R prime. Okay, and now this is your free part, that is this double bond O, and this is your Ag. So this negative charge will abstract this proton from here, and it will neutralize this oxygen atom, and after that there is a formation of this product R prime, and this is the hydrogen, and this is your other part, that is this one. Now see, there is an important thing is that after this after this step of reaction, then there is a insertion reaction will occur, that is insertion. So okay, we all know in organometallics, we all know the reaction mechanism in organometallics, and we all know how the insertion reaction will occur. So the insertion reaction is like this. This Ag will attack this, sorry, not Ag attack, this Ag will attach to this carbon, and this hydrogen will migrate to this silver atom, silver. Okay, so let's do, that is this R, that is R prime, and here is your oxygen, and this is your Ag, and here is your Ag, which is this Ag will migrate to this carbon, and hydrogen is migrate to this silver atom, and this is your rest part. Okay, sorry, there is oxygen between them, this is bonded. Okay, this is this. Now after that there is a insertion, and after that there is a reductive elimination. Okay, so reductive elimination, and we all know how the reductive elimination will occur, that is cis elimination, that is this hydrogen and this overall part will remove from the system in the form of carbonic acid, that is H2CO3. So removal of H2CO3, that is carbonic acid, and after that there is a formation of R prime, this is oxygen, and there is your Ag, and this is your Ag. Okay, so there is nothing, just two types of, now this will leave from the system like this way, that is two silver atom will precipitate or remove from the system, and after that you get this product. This is your overall aldehyde. Sorry, this is your overall ketone. Now there is a various kind of examples. So the question is also came on this topic only. This Fétizon'S reaction is in the GATE 2018 exam, so you can check over there, and I am writing this structure, and this question is directly taken from Carruthers, not in the detail section. This question is directly taken from Carruthers exercise. Okay, so this is your Ag2 on cellite. Now see, this is your allylic position. So this allylic position will react faster. So when it reacts faster, this will form the aldehyde. Okay, so this will form CH2. This is your OH, and this is your oxide. This is your aldehyde. Okay, this one. Now see, this oxygen has a lone pair of electron. This will attack over this carbon atom, and this is back from the towards oxygen. Now after that, this oxygen, this is your OH. Now this. Now you, in your reaction medium, the silver carbonate on cellite is present. So this OH will also convert it to corresponding to a ketone. So this is your lactol, and this is your corresponding lactone. Okay, lactone. Okay, so this is your overall product, and there is also various various examples and exercise. You can check any books that you can check Carruthers. Okay, so this is. Now see, there is one more concept, that is you have to know the reactivity order, and that is in this type of Fétizon'S oxidation, the reactivity order of first is benzylic alcohol, and after that allylic alcohol, then 2 degree and 1 degree. Okay, so this is the overall order of this reaction, and there is one more example you can take here, that is if this bond is, this is your above side and the hydrogen is in below side. So okay, if you put this Ag2CO3 and on this cellite, so the product which is formed in this reaction like this. Now this is your oxygen, and this bond here, like this is in backside, this hydrogen is in backside. Okay, so this is your overall product, and now you can easily make the mechanism like this way. After the one primary alcohol will oxidize to aldehyde, and after that this aldehyde will form this oxygen lone pair of oxygen atom will attack on the aldehyde, and there is a formation of this lactol, and after that the lactol will further oxidize to give your final lactone. Okay, this is your overall concept, this reaction. And if you have a structure like this, this is 2 degree and this is 1 degree, so this 2 degree alcohol will be much faster oxidized compared to this one, so you get the product like this. Okay, that's it. Okay, this is an overall concept of all these 3 types of oxidation reaction. Okay, I hope this video is useful for you, and that's it for this video. So thank you so much for watching.